hope you're having a great day. Welcome back to the STEM learning series on vamsivisions. I hope you've been enjoying my videos so far. Thanks to all my subscribers and viewers for your love and support. Did you know that the density of a liquid changes with its temperature? When you add hot water to cold water, the hot water rises to the top and the cold water sinks to the bottom. This is known as convection current. In today's video, we're going to see exactly the same. I hope you all find this entertaining. Before going into all that, I'm really happy to reintroduce our participants Swara and Shrilla to you all. Today they'll be showing us all the convection current experiment using water and food colouring. I'm looking forward to watching the experiment with you all. Over to you, Swara and Shrilla. Good luck!
Hi, my name is Swara. And my name is Shraddha. Today we will be experimenting convection currents. We will need a cup full of warm water, a jug full of tap water, a kettle, large jar, a piece of cling film, a sharp knife, a small cup, food colouring, any colour of your choice. Now we will make it. First, pour hot water into the bowl or cup. Then add your food colouring in. Then stir it. Then take your cling film and wrap it around the cup. Then take your elastic band to secure it from leaks. Then put your cup thing into the jar. Now pour cold water into your jar. Make sure it is heavy enough so that it does not float. Then take your knife and poke a hole into the jar.
Wow, look at this. The hot water mixed with the food colouring rises through the cold water. Eventually, the food colouring will mix with all of the water in the jar. The coloured water rising up in this experiment almost looks like a volcano eruption inside the glass jar. After watching Swara and Shraddha's video, I tried the bottle volcano experiment, which uses the convection current principle. As you can see, I filled this big jug 2/3 full with cold water, and I've also filled this small bottle with hot water, and I've also added some food colouring. And also I've attached a string to the small bottle. Now I'm going to lower it into the jar. Let's see what happens. Wow, look at this! I love this experiment. This experiment visually represents how heat rises in a liquid. This looks more like a mini volcano eruption like the previous one. The principle behind volcanoes is the same. They are formed by heat escaping from inside the earth. Now, Swara and Shraddha will explain the science behind it.
There are 3 ways in which heat can be transferred. When substances are in direct contact, heat can travel by conduction. When part of a substance is heated, the molecules begin to vibrate more violently. They knock against the molecules next to them, passing the heat energy on. Heat also moves through liquids and gases via convection. Very hot objects radiate their heat as electromagnetic waves. The sun radiates heat to Earth through the empty space, but fires and radiators also pass on their heat this way. Thank you. Very well done, Swara and Shraddha. I particularly liked both your enthusiasm and also how you clearly presented the experiment. Thank you so much, Swara and Shraddha, for participating. Stay tuned for the hot air balloon section, which is coming up next. Don't miss out. Let me explain how the convection current principle is used in hot air balloons. Look at this colourful pop-up card. This is the outside view of the hot air balloon with the pilot sending here.
Hot air balloons use convection to fill up with hot air and then rise into the sky. This is the inside of the hot air balloon. To make the balloon rise, the pilot switches on the gas burner, heating the air inside the balloon and making it expand. Hot air is coming from the gas burner here. The arrow represents the hot air rising here and the cold air sinking here. The hotter the air balloon, the faster the balloon rises. Now let me explain an interesting fact about heat vision. All hot objects give off invisible rays called infrared rays. These are invisible to the human eye, but some snakes can see them using their special heat detecting pits on their snouts. In the pitch darkness, a viper can see the blurry glowing shape of its prey, allowing it to sneak close enough to inflict a sudden deadly bite. We all refer to Robert Winston's science experiments and utterly amazing science experiment book to make this video. After watching this video, I'm happy to have a good understanding on heat transfer and convection current. My special thanks to Swara and Shraddha for doing this experiment and taking their time to share with us all today. I hope you all enjoyed watching this video. I recommend you to watch my earlier STEM videos if you're interested, and I'll leave a link to them in the description box down below. Like Swara and Shraddha, you can also participate in the STEM learning series by sending an email to stem@vamsivisions.co.uk to show your interest. I'll reply to your email as soon as possible with the next steps on how to get involved. So what are you waiting for? Drop an email to exhibit your STEM learning skills and passion using this platform. Also visit the Vamsivisions website at https://www.vamsivisions.co.uk to know more details. All the information is listed on there. Please like this video and subscribe to Vamsivisions to show your support. And with that note, I'm signing off for today. I'll see you all in another STEM episode next week. Have a good weekend, everyone. Bye!